We are now entering the first major section, the introduction and the link between drilling and the field life cycle. This section will help you understand why drilling engineers are involved far beyond simply operating a rig. Every oil or gas field passes through a life cycle. That life cycle typically includes exploration, appraisal, development, plateau production, decline, and abandonment. Drilling engineers contribute differently at each stage. Their responsibilities change depending on whether the well is for discovery, evaluation, production, intervention, or late field optimization. In the exploration phase, geologists and geophysicists identify possible prospects, and then drilling engineers work with them to design exploration wells. These wells are drilled to prove or disprove whether commercially significant hydrocarbons exist. The slide also mentions the term wildcat well, which is the slang term for the first exploration well drilled in a new basin or area. Exploration drilling is high risk because there is still major uncertainty, but it is also very important because it determines whether a field can move forward. This slide gives a detailed look at what is needed in a well drilling proposal. A drilling proposal usually includes the rig type, surface location, well target, depth, directional plan, wellbore diameter, bit specifications, geological cross-section, pore pressure profile, fracture pressure expectations, casing design, mud design, safety procedures, required data acquisition, drilling time estimate, and cost estimate. This shows that drilling engineering begins long before the bit touches the ground. Good drilling operations depend on strong planning and strong integration of geology, pressure prediction, mechanical design, and logistics. After a discovery is made, the project enters the appraisal or delineation phase. At this stage, more wells are drilled to better understand the size, continuity, and performance of the reservoir. The rig schedule becomes very important, and drilling engineers work closely with development geologists and reservoir engineers. This phase often includes decisions about whether wells should be temporarily suspended for future use, or permanently plugged and abandoned if they are no longer needed. Once the reservoir is considered commercially viable, the field enters the development phase. Here, wells are drilled primarily for production, and the development plan begins to be implemented at large scale. This phase is very important economically because it directly affects how fast the operator can generate revenue from the field. The slide also notes that as more wells are drilled, the learning curve improves, drilling times become shorter, and teams make better use of lessons learned from previous wells. Drilling is also important during the reservoir management phase. At this stage, wells may need interventions such as secondary cementing, tubing replacement, recompletion, well deepening, or milling operations. These activities are not necessarily about drilling entirely new wells, but they still require drilling-related engineering knowledge and operational control. This is a very important idea. Drilling engineering does not stop after the initial well is completed. When a field reaches the decline phase, drilling can still play an important role. The slide gives examples such as infill drilling, where new wells are drilled between existing wells to reduce drainage area and improve recovery, and pattern realignment, where producer and injector patterns are adjusted to optimize water flood or gas injection performance. So even late in field life, drilling remains an important tool for improving production efficiency and recovery factor. This discussion slide asks which phase of the field life cycle is the most critical for long-term productivity. You can think before we know answer in next slide. The answer is the development phase, because this is when the production wells and infrastructure are actually implemented based on everything learned earlier. A well-executed development phase can maximize recovery, improve reservoir performance, and reduce operational cost over the life of the field. This is a very good teaching point because it shows that success depends not only on making a discovery, but on developing it correctly.